Today we're going to talk about how to determine whether or not a triangle exists given three side lengths. So I need to make sure that you have this piece of paper on your desk as well as you have at least 2 highlighters on your desk. So pause this video if you're not ready to go. Otherwise, highlight your title and let's get started. So my goal today, which is to determine whether or not a triangle exists based on the given side lengths. So what needs to happen in order for a triangle to exist? The 3 sides, let me write in black, hold on. The 3 sides touch each other to form a closed shape. So the 3 sides have to touch each other in order to form a closed shape. So this side and my third side all must be touching to keep my closed shape. So I have what's called the triangle inequality theorem. And what the triangle inequality theorem tells me is that the triangle exists if 2 sides are larger, or I'll say greater. 2 sides, actually hold on. The triangle exists if 2 sides are added together to be greater than the third side. So I have to try all possible combinations to determine if 2 sides, when they're added together, if they're going to be greater than the third side. So if I take A and I take B and I add them up, it has to be greater than C. And if I take B and I take C and I add them up, the number that I get has to be greater than A in all 3 combinations. So you have to test all of them. I have to test A plus B, and that has to be greater than C. And B plus C has to be greater than A. And A plus C has to be greater than B. All 3 possibilities have to happen in order for me to say yes, a triangle exists. If at any one of these I say no, the sum is not greater, then the triangle automatically does not exist. So let's go ahead and let's look at these following examples. It says, is it possible to draw a triangle with the following sides? So I'm given the sides 12, 11, and 17. So I don't know which one's A, which one's B, and which one's C, so I'm just going to try all 3 possible combinations. I'm going to first test 12 plus 11, and I want to know if that's greater than 17. 12 plus 11 is what? It's 23. Is 23 greater than 17? Yes. All right, 1/3 done. So now I'm going to test 12 plus 17, and I want to know if that's greater than 11. Is 12 plus 17 greater than 11? Yes, because 12 plus 17 is 29. That's greater than 11. So now I got to test the last combination. 11 plus 17, is that greater than 12? 11 plus 17 is 28. Is 28 greater than 12? Yes. So let's go to the next one. Try the first combination with 24, 31, and 55. So 24 plus 31, is that greater than 55? So 24 plus 31 is 55. Is 55 greater than 55? No. So because I said no, I'm going to instantly say no, a triangle doesn't exist. And up here, I would definitely say yes, it does exist. I forgot that part. So let's do one more together. And then we'll kind of cheat the system here and think about it. So let's try this one. I'm going to do 1.7 plus 2.3, and I want to know if that's greater than 3.1. 1.7 plus 2.3, is that greater than, well, let's see, 1.7 plus 2.3 is 4. 4 is greater than 3.1, so yes, that works. So now I have 1.7 plus 3.1, is that greater than 2.3? 1.7 and 3.1, that's 4.8. That's greater than 2.3. And now I have 2.3 plus 3.1, is that greater than 1.7? Well, 2.3 is already greater than 1.7, so anything I add to it's still going to be greater. So yes, a triangle does exist with these lengths. So I could take out a ruler and measure 1.7, 2.3, and 3.1, and I would get a closed shape. Doing this 3 times is unnecessary because notice this last one. 2.3 and 3.1 were my 2 larger sides, so obviously my 2 larger sides added together is going to be greater than my smallest side. So instead of testing all 3 possible combinations, we have a shortcut that we can do. So we're going to come down here, and it says, can we come up with a simpler way, it's not highlight in black, can I come up with a simpler way to prove triangle existence? Well, yes, I can. All I have to do is to determine if the 2 smaller sides add up to be larger than the largest side. So I have to add up the 2 smaller sides to make sure it is greater than the third side, which I'm going to call the longest side. So instead of having to test all 3 possible combinations every single time, I can cheat the system where all I have to do is add up the 2 smaller sides to make sure it's greater than the third side, which is the longest side. So if I go up and I look at this number 4 example, I'm going to find my 2 smaller sides, so 7 and 4. So I'm going to take 7 plus 4, and I want to know if it's greater than 12. Well, 7 plus 4 is 11. Is 11 greater than 12? No. So I can instantly say, no, this triangle does not exist. Let's look at the next one. Find my 2 smaller sides. Well, notice here they're all the same, so I'm going to just pick the first 2. So 1 plus 1, I want to know if that's greater than 1. 1 plus 1 is 2. Is 2 greater than 1? Yes. So I can instantly say, yes, a triangle exists. So go ahead and pause this video and try the last 2 on your own, and then we'll go over them. So if I look at number 6, I need to take the 2 smaller sides. So 12 plus 15, and I want to know if it's greater than 20. 12 plus 15 is 27. Is 27 greater than 20? Yes. So a triangle exists. Last one, 7 plus 10 is greater than 20, my 2 smaller sides. So 7 plus 10 is 17. Is 17 greater than 20? No. So a triangle does not exist. So when you're good, flip your paper. So now I have to talk about, well, what's going to happen if I'm given 2 sides and I'm asked to find a possible third side? What would be possible? What would that third possible side be? So notice, if I just come down here and I think about this first example, and I'm just going to write it over here, but you don't have to write it as long as you're paying attention. So I have the numbers 4 and 7. So 4 and 7 have 2 possibilities. Actually, they have 3 possibilities. But we'll say 2 for, well, we'll say 3. Okay, fine. So 4 and 7 could be the 2 smallest ones. They could be the 2 largest ones. Or they could say where 4 is the smallest and 7 is the largest, and I'm missing my middle number. So usually this last case isn't as more likely as the first 2. So I want to know how I would find this one or how I would find this one. Well, this deals with our triangle existence inequality, that these two have to add up to be greater than this one. So 4 plus 7 is 11, so 11 has to be greater, 11 has to be greater than this side. So what could this side be? Well, it could be 10, it could be 9, it could be 8, it could be 7, well, it could be 6, but if it was 6, then it would come down to this one, because 6 is, this wouldn't be my middle one, this would now be my taller one. But it could be 6, it could be 5, it could be any of those possibilities. So it's anything less than 11, right? Because it's 10, 9, 8, 7, something around here. So now let's look at this possibility. These two have to add up to be greater than 7. So what numbers add up to be greater than 7? Well, let's start with the most basic number, 1. 1 plus 4 is 5, that doesn't work. 2 plus 4 is 6, that doesn't work. 3 plus 4 is 7, that doesn't work. So obviously this case can't work, but 5 would work, or 6 would work, or 7 would work. Any of those numbers would work to be able to get it. So that's what I'm trying to do on these problems, is I'm trying to sit here and say, okay, well, what would that third potential side be if I'm only given 2 sides? So you're probably sitting here thinking, oh my gosh, I have no idea what she's talking about. Well, there's a nice, lovely shortcut. So, but I want to highlight all of this fun stuff first. So what we're going to do is we are going to add, let me not write in a highlighter, we're going to add the 2 lengths to get the max, and then we're going to subtract the 2 lengths to get the min range. So I'm going to, when I have 2 numbers, to get that range, I don't know whether or not it's going to be the largest value of the triangle or the smallest side of the triangle. So I add the 2 lengths to get the maximum range, and I subtract the 2 lengths to get the minimum range. So if I look at the numbers 2 and 5, I'm going to add 2 and 5 to get 7, that's the max, and I'm going to subtract 2 and 5 to get 3. So any number between 3 and 7 will make a triangle exist, but 3 will not make it exist and 7 won't make it exist. So how we write it, anything in between, is less than x less than. This notation is the notation that we're going to use to represent everything in between but not including. It's always less than x less than. Since this is the notation that you would use, and we also say it's between 3 and 7, but not including 3 and 7, another way that you could write this is you could say 4 is less than or equal to x, which is less than or equal to 6, because really anything between 3 and 7 is 4, 5, and 6. So you could write it this way, but this is the famous way of writing it. You have to include this notation if you want to get full credit. So if we go down here and we look at some of these problems, it says determine the possible range for the third side of the triangle given the other 2 sides. So I would, first off, let's make that straight as possible. I'm going to subtract these 2 values to get my end point, my minimum range. So 7 minus 4 is 3. And I'm going to add those 2 values to get my maximum range. So 4 plus 7 is 11. And now I just do my range. So what this means is any number between 3 and 11, but not including 3 and 11, would make a triangle exist. So my possible side could be 4, because 4, 4, and 7 would make a triangle exist, because 8 is greater than 7. Or 4, 5, and 7, 4, 5, and 6, 4, 7, and 7, 4, 7, and 8, so on and so forth, all the way to 11, but not including 11. Let's do the next one. Subtract these 2, I get 3. add these two, I get 25, and it's always less than x less than. I will tell you, we are going to try to trick you on multiple choice type questions where we would flip these to be greater than x greater than, and you would have to know that that is wrong. So just kind of as a friendly little tip. If we do one more together, I'm going to subtract these two, I get 4. I'm now going to add those two and get 10, and it's always less than x less than. So go ahead and pause these two videos. How about you pause this video and you practice these two problems and then unpause it, and the answers will be on the board. So the problems for the last two examples are shown. Anything between 3 and 23, and anything between 2 and 32. So we have a bunch of practice problems here. So number 1 on this practice problem, you can go ahead and cross out because we don't have anything for this one. I don't have a triangle as a typo. So I want you to practice these problems 2 through 5. Oh, I lied, 2 through 7, but somehow number 6 got cut out. So solve these 5 problems, and when you finish, we'll go over them together. So it says, can a triangle be formed by the following sides? So I have to add up my two smaller sides. So 9 plus 8, I want to know if that's greater than 17. 9 plus 8 is 17. That is not greater than 17, so no, a triangle cannot be formed. In the next one, can a triangle be formed with the following sides? I got to find my two smallest sides, which is 12 and 4. So 12 plus 4 is greater than 15. Is 16 greater than 15? Yes, so I can say yes, a triangle can be formed. Next one, if the two sides given are the smallest side of the triangle, then what is the maximum value of that the third side can be? So I would add these two to get 33, and then I'd subtract these two to get 9. So the maximum value that it could be is 32. Last one, the two sides of a triangle, not the last one, the next one, I can't speak today. The two sides of a triangle are 14 and 8. What is the possible range for the third side? So I'd subtract these two to get 6, and then I'd add these two to get 22, and then it's less than x less than, because this means anything in between. Last ones, come up with lengths of a triangle such that angle A is the largest, angle B is the smallest, and a triangle exists. So if I draw a picture here, A is the biggest, B is the smallest, so largest, smallest, medium. So, and a triangle exists. So you can really make up whatever you want to be. So if A is the largest, so I'm going to label this out. A is the largest, B is the smallest, and let's pick C is somewhere in the middle. So let's pick 7 to be the smallest. I just picked that number up. And let's pick 12 to be the largest. So 7 plus what is greater than 12? Well, 7 plus 5 is 12. So how about 7 and 6? 7 plus 6 is 13. That's greater than 12. Done. B is the smallest. Side A is the largest. I'm done.